Alright, so evaluating limits analytically. Now sometimes evaluating limits analytically is referred to as plug and chug type of stuff, where you take the actual number and plug it in and see what the response is you get. But as you guys can see in the past couple of lessons, if we try to plug in those numbers, we're going to get an indeterminate response. So we had to look at it graphically and on a table. So right now I'm going to show you the methods for analytically. Okay. All right, and this from paper from, yeah, it's just a paper from Purdue, I think. Yep, it is. This is that one. Okay, so evaluating limits analytically. So basically use direct substitution as your first line of attack. Now, if you get 0, 0, you have to try a different method. So that's this one. So if the problem involves a polynomial divided by polynomial, and when you use direct substitution you get 0 divided by 0, then go back to the beginning, factor and cancel, and then try direct substitution again. Okay? Now, if the problem involves a radical expression and direct substitution gives you 0 over 0, so radical is where square root's involved, or some kind of root involved, then rationalize, in other words, multiply the conjugate in the form of 1. And then try to simplify. So sometimes you may need to rationalize the denominator, sometimes you may need to rationalize the numerator, just to get it out of its funk, because it will help you. Alright, now if it involves a rational expression in the numerator or the denominator, then simplify this so that we just get one function. So in other words, f of x over g of x minus 1/7, then simplify by multiplying in the form of 1 so you have a single rational form. So in other words, I multiply top and bottom by g of x over 7, and I get f of x times 7 minus g of x over h of x times g of x times 7. Okay. Now if it involves a trig function, then try to get it into one of these two special trig limit forms. Okay, so in other words, try to get it into this form so you can simplify it to 1. Or try to get it into this form to simplify to 0, or this form and simplify to 1, or this form and simplify to 0. Okay, so those are some of the methods. So I'm going to show you the actual problems. Okay, now if the problem involves delta x and direct substitution gives you 0 over 0, then simplify the expression. In some cases you'll have to use one of the above cases. This is when you're using the difference quotient. If all of the above failed, then try using a table of values or a graph. You want to be able to do these methods up here, because if you choose on doing like some kind of class in college, you're going to have to rely on your actual stuff. Okay, so some exact problems. The limit of x to the third as x approaches -2, we just plug in, we get -8, so that's our limit. Okay, now this one, if we do plug in 2, this is the limit of 2 minus x over x squared minus 4 as x approaches 2. I'm going to get 2 minus 2 on top, which is 0, and 2 squared minus 4 on bottom, which is also 0. Okay, so since this is an indeterminate form, we try factor and cancel. So on top and bottom, I factor out a -1 on top. I factor that into x minus 2 times x plus 2. Okay, well, if you kind of notice, I'm going to be left with a -1 up here, because these two are going to simplify to 1s, and so I'm left with -1 over x plus 2. Now if I plug in 2 for my limit, I should be able to get -1/4. So that's how you do this stuff. It's really easy once you start getting into it. Okay, now here's the radicals I wanted to talk to you about. Alright, square root of 2 plus x minus square root of 2 over x as the limit approaches 0. Okay, so I plug in 0 and I get 0 over 0, so that's an issue. Okay, so now if you notice, my whole function is already sort of rationalized, but it's rationalized to where it's not out in the denominator. So I'm going to rationalize it again so it is in the denominator, because that will help. So if you notice, this is the form up here with a minus sign in between. I'm going to multiply top and bottom by the conjugate, which is the same thing but with a plus in between. Okay, now when I get done multiplying it, this top part is just going to turn into the difference of the two parts. That's actually a difference of perfect squares. Okay, so it becomes 2 plus x minus 2. Alright, and this bottom part, I'm just going to leave it as x times whatever this other part was, the conjugate. Okay, now when I do that, okay, what I'm left with is x. Well, the 2's cancel out, so the 2 minus 2 cancels out to 0. I'm left with an x up here and an x down here. Well, now I have an x and an x. I can simplify those to 1, and now I can actually plug in 0 and get the answer to be 1 over 2 root 2. Okay, the radical in the denominator like this is okay for limits. For limits, we want that. Okay, now if we have a complex fraction, I don't see this happening very often, but you find if you try to do everything, you're going to get 0 over 0. So you multiply by the common denominator to top and bottom. So the one denominator is x plus 4, the other one is 4, so the common denominator is x plus 4 times 4. And so I multiply top and bottom by that, okay, and I simplify everything and I get 4 minus x plus 4 over x times x plus 4 times 4. Okay, so these two are going to cancel out. Well, those two are going to turn into, yep, they're going to cancel out, and I'm left with a negative x on top and an x on the bottom. Okay, well, if I cancel out these two, there's not cancel out, but they simplify to 1's, and I'm left with a negative 1 up top. I'm not going to multiply that in just because it just makes the job a whole lot easier. So just leave it as is. Okay? And I just plug in 0. And 0 plus 4 is 4, and 4 times 4 is 16. So this whole limit becomes negative 1/16. Okay? Alright, and then the trig right here, it's going to be a little bit difficult if you try to plug in theta as 0. But you're going to be using those forms that we just talked about, those simplified cases. I believe it was right up here. You're going to be using these to simplify it the best you can. Okay? All right. And so that is pretty much it for evaluating limits analytically. I don't think we're going to get more complicated than possibly a complex fraction. But, you guys, I hope you enjoyed this lesson, and I'll talk to you later. Bye.